All right, so I want to take a look at a couple more problems here with vertex form and things that we're going to be asked to do. So again, when you're given a problem like this, the first thing that you should be able to do, and you should be able to just, again, look at these problems and find the vertex, the axis of symmetry, and then does it have a min or a max, just based on really the formula here. So the vertex is the opposite of h, so that would be a -3, and it's the same as k, which is -4. And then the axis of symmetry is always x equals -3. And then without graphing this, I want to look at how we can find whether it has a min or a max. Again, we talked about if the parabola goes up, it's going to have a minimum. If the parabola goes down, it's going to have a maximum. So if we look at this 2, that tells me the parabola is going to go up, which means it's going to have a minimum. And the minimum is always the y value of the vertex, which would be -4. Okay, so again, looking at another problem. And we'll go ahead and graph this one just to show it, but the vertex is the opposite of h, which is 4. And then the k value, which is -2. The axis of symmetry is the line x equals 4. It's always the x value of the vertex. Does this have a min or a max? 3 tells me it's going to go up. So this is going to have a min, and it's always the y value of the vertex, so a minimum at -2. And the last thing I want to talk about, domain and range. When you look at a problem like this, the domain, again, a parabola, and I'm going to look at this graph real quick, and then we'll talk about the domain and range from the graph. So if we go to this problem right here and look at Desmos, I have a new equation. I'm going to put y equals, okay, there was a 3 parentheses. Let's see if I can find it here. 3 parentheses. Yeah, I can't see that. There we go. X minus 4 squared. Okay, so x minus 4. No, this is going to go inside 3 parentheses. X minus 4. Close the parentheses, square it. And then it was a -2 outside here. Okay, so the parabola looks like that. So again, it goes up. It has a minimum value right here at -2. So let's go ahead and talk about domain and range of this parabola. As it goes to the left and right, it's going to go forever and ever and ever. If I zoom out, it keeps going forever and ever and ever. So the domain of this problem is all real numbers, okay? And it's always all real numbers. This is a gimme point on a test, okay? So it's always all real numbers for domain, okay, which would be -infinity to +infinity. The range, however, is the y values. And what does the y values do? Again, if we looked at a rough sketch of this, okay, parabola, it looks something like this. Whoop, goes up, it's a little skinnier. Okay, so what does that parabola do? Well, it starts at -2, like we said, and it goes up. So the range for this would be -2 to +infinity. And notice I put a bracket around the -2 because it is included in the range. So I don't think there's many problems asking you that on Delta Math, but I want you to be able to do those types of problems. Okay. All right, so let's take a look at this last problem. There's a couple of these on your homework. So this is when I actually give you the vertex and I give you a point, and I want you to write the equation. So in this problem, okay, and it talks about the picture shows the jump of a dolphin. What quadratic function models the parabola? So again, when a dolphin jumps out of the water, it comes up and it forms a parabolic path. So in these problems, I'm going to give you the vertex and I'm going to give you some random point that's on the parabola. We have to understand that these points right here have special meaning to our formula. This is my h, this is my k, this is my x, and this is my y, because this is the random ordered pair on the parabola. This is my vertex. So when I do this problem, all I'm going to do is use this formula right here, okay? So I'm going to use y equals a parentheses x minus h squared plus k, and I'm going to have a vertex and a point, okay? So the vertex that I gave you in that last problem was 3, 7. And the point that I'm dealing with, the point that I'm dealing with is 9, 4. So again, that's not very good, 4. Make sure you can see that. 9, 4. Okay, this is my H, this is my K, this is my X, this is my Y. All I'm going to do is plug those values into this equation and find A. So I'm going to plug in 4 for Y. I don't know what A is, so I leave that open. I'm going to plug in 9 for X. I'm going to plug in my 3 for H. Again, it's a minus 3 because that's what the formula has. Okay, and then my K is plus 7. So now, excuse me, how do I solve this? Well, it's a simple order of operations problem solving for A. So I have 4 equals A. I'm going to take care of parentheses here, which is 6 squared plus 7. 4 equals 6 squared is 36A plus 7. Now solve for A. So subtract 7, 4, or negative 3. 4 minus 7 is negative 3 equals 36A. I'm going to divide by 36. And I get negative 1 over 12 equals A. So now it asks you to write the equation y equals A times X minus H squared plus K. I'm going to always leave Y and X when I write the equation. So it'll be Y equals, I just found A to be negative 1 over 12, X minus 3 plus 7 from the vertex, right? My vertex is HK, and that was the vertex in this problem. So does that make sense looking at the picture? Yeah, it goes down. It's a little bit wider. So again, there's a couple problems that look like that. So you should be able to put in, for what do? You need to sub in your X, your Y, your H, and your K and find A. And then once you find A, you got to go back and plug in A, H, and K to write your answer as a parabola. So I want to take a look at a couple of your homeworks that you're going to have on Delta Math, and just a few problems of what they look like, because they're a little bit different than what I asked. But you're going to have some of these transformation discovery thing where you match up. Again, that's adding the HK. We did that again in 2.7 in family of functions, so I'm not too worried about those. Transformations of functions. I want to look at these. Now, these will just be parabolas, but you're going to see in this example it's not. So again, what did it do here? It flipped about the x-axis and it shifted to the right. So there's going to be a negative. That's what makes it flip. And then it shifts to the right. So there'd be a minus 4 in parentheses as I'm doing those. So again, make sure you remember your shifts up, down, left, right, HK, and what those do. Okay. So parabola features, you're going to have a couple problems that look like this. Okay, type in the answer. All this is asking for is the vertex. So again, you got to know the vertex is this ordered pair. You would type in negative 6, 1. Okay, so it's 1 point. And you would type in negative 6, 1. For those problems, I think those are pretty simple. You have the same exact thing for finding the axis of symmetry. Okay, select form to find the quadratic. Here's the min or the max. So quadratic function is going to ask you to select the form. Well, we're dealing with vertex form, so do vertex form. And then now, what's the minimum or the maximum? Well, you must find the max value of the function, choose the form that would like to see the order to answer the question most effectively. So for this, we're going to find the maximum. Why is there a maximum? Because it's negative here. And the maximum is always the y value. Let's make sure that's what they want, okay, of the vertex. Again, how did I know that was? It's the y value of the vertex, which is always my k here. So there's going to be a few problems that look like that. And then you got 2 at the end, like the dolphin problem. So take your time. If you need help, make sure you're asking. We're starting a new chapter. This is really what I consider the beginning of Algebra 2 material. So if you're falling behind, you need to make sure you're asking me questions. We cannot let this stuff linger here. We're getting into the real Algebra 2 portion of this. Stuff we're doing in this chapter will go on for the rest of the year through mid-January. So please, please, please ask questions. Hope you guys are having a good day, and see you later.